Hi, welcome to BC Video 9.28 Part 1, Introduction to Series and Partial Sums. Okay, so 9.2, now we've left sequences, now we're at series, and we're going to look at the convergence and divergence of series. And series, if you remember, is the sum of the terms of a sequence. So it is a sum, and therefore we can use the summation notation, the sigma notation, n goes from 1 to infinity of a subscript n, where you replace all those n's by the n's by 1, and then 2, and then 3, all the way to infinity, which is forever, and you add those terms together. So again, the domain is 1, 2, 3. A series is the sum of the terms of an infinite sequence, and these will be infinite sequence series and from infinite sequences. So remember, the notation for a sequence is braces, an. So for example, if that sequence was n, it would be 1, 2, 3. The corresponding series would be, we'd add all those up together, and that would be 1 plus 2 plus 3. Now you can easily see that the series diverges, because if you keep adding these large numbers, it'll just keep getting larger and larger. And you can also see that the sequence it came from, the limit as n goes to infinity of n is infinity, so the sequence also diverges. But that won't always be true, and I'll show you that in a second. Okay, so take for example the sequence 1 over n, 1, 1/2, 1/3, 1/4. Now you can see that if you try to decide whether the sequence converges or diverges, you'll have the limit as n goes to infinity of your an, which is the limit as n goes to infinity of 1 over n. Well, of course, 1 over infinity is 0, and you can see that's getting closer and closer to 0. So the sequence converges to 0. The corresponding series for this one, 1 plus 1/2 plus 1/3 plus 1/4, as it turns out, diverges, and I'll show you that on the next page. As opposed to, if you take the sequence 1/2 to the n minus 1, which means if you start with n equals 1, this becomes 1/2 to the 0, which is 1, and then you keep multiplying by 1/2. The sequence itself, limit as n goes to infinity of an, will become 1 over 2 to the n minus 1, with n going to infinity, which will be 1 over 2 to the infinity, 1 over infinity is 0. So it converges to 0. However, the series 1/2 to the n minus 1, which is 1 plus 1/2 plus 1/4, as you will see, converges to 2. So the sequence and the series do not converge to the same thing. Here, the sequence converged to a number, this corresponding series diverged. So you really don't know going in. So why is it that 1 plus 1/2 plus 1/3 plus 1/4, etc. diverges? Well, that's because if you add them up, 1 plus 1/2 is 0.5. 1/3 is 0.3 repeating, so that would be 1.83 repeating. If you added 0.25 to that, you would already be over 2. So you can see if I keep going, now I'll have 2.2. It won't take long before I'll be 3. It'll take a bit longer before I get to 4. It'll take a bit longer, but I will get to 5, etc. As opposed to here, I keep adding. If I add 0.25 to this, I get 1.75. I add 0.125, I get 1.875, etc., etc., etc. So, and I'm going to say this a lot. In each case, the terms of the series are getting smaller. What's happening is these aren't getting small enough, fast enough for it to converge. These terms are getting small enough, fast enough for the series to converge. Okay, so if we take this, okay, so the thing is, this is going to be a little confusing for you, especially for multiple choice. There is not a unique way to write the same series. Notice all of these are the same series. So one way to write this is n goes from 1 to infinity, summation of n, which would be 1 plus 2 plus 3, etc. But I could write it as summation n goes from 0 to infinity of n plus 1, because if I start at 0, 0 plus 1 is 1, plus the next one would be 1, 1 plus 1 is 2. I'll get the same series. This will give the same series, so will this. Now, when you get an answer of a series and it's multiple choice, and there'll be 5 choices, here's how you can change your series to look like theirs. Notice if I subtract 1 from the lower limit of summation, I will have to add 1 to the expression for the sequence. If I add 1, like the green here, I'm adding 1 to the lower limit of summation, then I'd have to counteract that by subtracting 1. So you can see here, to get from 1 to 5, I add 4. So to remain equivalent, I'll have to subtract 4. All right, now a sequence of partial sums, which is S1, comma, S2, comma, S3. I do want to emphasize this is a sequence. You'll see how this ties in with series, where Sn is the sum of the first n terms of the series. Now this is going to be finite because S1 means the sum of the first 1 terms, S2 means the sum of the first 2 terms, S3 means the sum of the first 3 terms. So Sn means the sum of the first n terms, period. This doesn't go on after that. So what happens is, if I had a sequence, 1/2 to the n, and I had the corresponding series, what I'm saying is S1 is the first term of the sequence or series for that matter. S2 is the sum of the first 2 terms of the sequence or the series, which is 1/2 plus 1/4. S3 would be the sum of the first 3 terms. Now, here's how it works. For the infinite series, this is the definition of a convergent or divergent series. For the infinite series summation an, the nth partial sum is given by Sn equals a1 plus a2 plus a3 all the way up to plus an. If the sequence of partial sums Sn converges to a number S, then we say that the series An converges. So remember, it is a sequence. So if we talk about the convergence of a sequence, that means if the limit as n goes to infinity of Sn equals a particular number, then that number we're going to call S. The limit S is called the sum of the series. If Sn diverges, then the series diverges. So if you find the limit as n goes to infinity of Sn and it diverges, then your corresponding series diverges. Now, you will be given the formula for Sn. You don't have to worry about coming up with it because getting the formula for Sn from the formula for summation An is very difficult and you will not